Hi friends, with the knowledge of MOS capacitors, we are now ready to learn more about MOSFET. Why we are interested in MOSFET is because this is the transistor that is being used in most of the modern day electronic devices. With this video, we are starting our discussion on MOSFET, metal oxide semiconductor field effect transistors. With our knowledge on MOS capacitors, we shall now start our discussion on MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. If you remember the earlier analogy where a pipe carrying water, the water is being controlled by the tap which is put at the center. By adjusting the tap, you are controlling the water flow. Field effect transistors are of this type, and the metal oxide semiconductor field effect transistor is such a semiconductor device where the current flow is being controlled by the voltage applied at the third node. And MOSFET is commonly used in the field of power electronics in industries. Generally, MOSFETs are classified into N MOSFET, P MOSFET and C MOSFET. We will see the various differences regarding these, the idea behind this classification in our session. Now we shall look into the structure of a MOSFET. If you remember the MOS capacitor, where we had a semiconductor separated by an oxide layer which had a metal contact at the top. This was MOS capacitor, and we were applying voltage across metal and the semiconductor. Along with this MOS capacitance effect, in case of MOSFET, we have this part forms the MOS capacitance, the metal, the oxide and the semiconductor. Here it is the p-type semiconductor. Along with this, we are having a source which is an N plus region, and also we are having a drain which is also an N plus region along with the gate. So we are having three terminals similar to BJT where we had emitter, base and collector. In case of MOSFET, we will have source, gate and drain. This figure shows you the three-dimensional structure of a MOSFET. If we just want to plot it in a 2D, this can be the structure of MOSFET. We are having a source, and a metal gate and drain. The basic element is MOS capacitor itself, which is being constituted by the metal, the dielectric, which is an oxide in case of metal oxide semiconductor FET, and the semiconductor substrate. This forms the MOS capacitor. Now let us see the working principle of the MOSFET. For that, look into the diagram where the connection is shown. The voltage applied to the various leads is shown. We have a gate to source voltage VGS connected between the source and gate, and a drain to source voltage which is connected between the drain and the source, and also we have a base to source or back contact to source voltage connection. The working principle of MOSFET depends on MOS capacitors. The semiconductor surface below the oxide layer, this area, I will change the color, this area which is between the source and the drain, can be inverted using the applied voltage at the gate. If you remember, inversion happens when VG is very much greater than 0, if you remember the MOS capacitors. This is the case of P substrate. If it was N substrate, the inversion happens when Vg is much less than 0. So we are just explaining using one type, and then you can relate it to the other type as normally we do. And when we apply positive gate voltage, holes at this junction ripples. It is pushed downwards, and that causes inversion, if you remember the concept of MOS capacitor. And because of the positive voltage applied at the gate, holes are repelled. At the same time, minority carriers comes to accumulate here, which cause the inversion. Not only the minority carriers from the substrate, in this case electrons from the N plus source and drain also gets attracted, and that forms a N channel between the source and the drain, and this channel will allow current flow between source and drain, which can be controlled by the applied voltage here, the gate voltage. The opposite is applicable for the N substrate type of MOSFET. So the working is very simple. In the current flow between the source and drain is controlled by the applied voltage in the third node, which is the gate. This is what is required or the objective of a transistor. Flow of current between two nodes controlled by the third node. Now, how NMOS and PMOS MOSFETs are formed? You might have already realized what is happening. In case of NMOS, we are having a p-type substrate. And when gate voltage is applied, a channel forms between the source and the drain. Which is helping the movement of current between source and drain. In case of PMOS, the substrate is N-type, and on application of the gate voltage, a P channel of holes is formed between source and drain, which could be controlled by the gate voltage and thus control the current between source and drain. The idea is quite simple. Now, there is another classification possible in case of the MOSFET, which is the depletion type MOSFET and enhancement type MOSFET. There is a E missing here. Depletion type MOSFET and an enhancement type MOSFET. In this classification, the difference can be explained from the figure. In the depletion type, a channel is already been created even before the application of gate voltage, and the control of current is done by the gate voltage by the pinching off of the channel, by controlling the channel. This type of MOSFET is known as the depletion type MOSFET. And in case of enhancement type MOSFET, you can see channel is absent between source and drain, and here the control of current flow between source and drain is due to the inversion brought about by the applied gate voltage. The simple example of, or remember the working of MOS capacitor, the same explanation. Now, we have seen different types of MOSFET. We will just try to see the symbol of each type. In case of enhancement type, you can see a gap which denotes that there is no channel at the beginning. Only after the application of gate voltage the channel is formed. That is the case of enhancement. In case of depletion, we are having a continuous line here which shows that the depletion region is already present, and the arrow will be towards inside in case of N channel. Both case, the arrow is inside, towards the inside, and for P channel the arrow is towards the outer side. This is how the symbol of the various type of MOSFETs are drawn. So, the basic element or constituent of a MOSFET is the MOS capacitor itself, and the controlling of current flowing between drain and source is brought about by the applied gate voltage.